Dividing polynomials, long division. Dividing by a monomial. If a, b, and c are monomials and b is non-zero, then a plus c divided by b is equal to a divided by b plus c divided by b. In words, to divide a polynomial by a monomial, divide each term of the polynomial by the monomial. In this example, divide 10c to the fifth plus 8c to the third minus 4c squared by 2c squared. The first step is to write three fractions. So my first fraction is 10c to the fifth divided by 2c squared plus my second fraction is 8c to the third divided by 2c squared minus my third fraction, 4c squared divided by 2c squared. Then I want to reduce each fraction. 10 divided by 2 is 5. C to the fifth divided by c squared is c to the third. Bring down the plus sign. 8 divided by 2 is 4. C to the third divided by c squared is c to the first. Bring down my minus sign. 4 divided by 2 is 2, and c squared divided by c squared cancel out. My final answer is 5c to the third plus 4c minus 2. In this example, divide negative 2b to the fifth plus 9b to the fourth minus 15b by negative 3b to the third. Since I have a trinomial in the numerator, I'm going to have three fractions. So I have negative 2b to the fifth divided by negative 3b to the third plus 9b to the fourth divided by negative 3b to the third. For this problem, I'm going to keep the minus sign with the 15 plus negative 15b divided by negative 3b to the third. Since my denominator has a negative sign, it's going to be easier to reduce this if I keep the negative with the 15. Negative 2 divided by negative 3 is just 2/3. B to the fifth divided by b to the third is b squared. I can either write that beside the 2 or behind the fraction. 9 divided by negative 3 is a negative 3. B to the fourth divided by b to the third is just b to the first. Bring down my plus sign. Negative 15 divided by negative 3 is 5. B divided by b to the third is b squared in the denominator. So my final answer is 2/3 b squared minus 3b plus 5 over b squared. In this example, divide 6w to the fifth p plus 12w to the fourth p squared minus 2w to the third p to the third, all divided by 6w squared p. Since my numerator is a trinomial, I'm going to have three fractions. My first fraction is 6w to the fifth p divided by 6w squared p plus my second fraction is 12w to the fourth p to the second divided by 6w squared p minus 2w to the third p to the third divided by 6w squared p for the third fraction. Reducing, 6 divided by 6 is 1. W to the fifth divided by w squared is w to the third, and the p divided by p cancels to be 1. Plus, 12 divided by 6 is 2. W to the fourth divided by w to the second is w squared, and p squared divided by p is p to the first. Minus, 2 divided by 6 reduces to 1/3. W to the third divided by w squared is w, and then p to the third divided by p is p squared. So my final answer is w to the third plus 2w squared p minus 1/3 wp squared. Dividing by a binomial. Long division can be used to divide a polynomial by a binomial. The steps are similar to performing long division with numbers. We can verify our work by checking that the divisor times the quotient plus the remainder equals the dividend. First, let's review long division. We have a fraction, 3,547 divided by 14. So to write that as long division, 14 is on the outside, 3,547 is on the inside. 14 is our divisor, 3,547 is the dividend. 14 will go into 35 2 times. 2 times 14 is 28, so I write down my minus 28. Subtract and bring down the next digit of the dividend. So 35 take away 28 is 7. Bring down the 4 and I have 74. 14 will go into 74 5 times. 5 times 14 equals 70, so I write my minus 70. Subtract and bring down the next digit of the dividend. 74 take away 70 is 4. Bringing down the 7, I have 47. 14 goes into 47 3 times. 3 times 14 equals 42, so I write down my minus 42. Subtract. 47 minus 42 is 5. That's your remainder. Your quotient is 253. 3,547 divided by 14 equals 253 plus 5 over 14. To check, my divisor is 14 times my quotient of 253 plus my remainder of 5 equals my dividend, which is the numerator, 3,547. In this example, we're going to perform the long division, 2x squared plus 11x plus 15 divided by x plus 3. So I'm going to start by writing the x plus 3 on the outside of my division symbol and my 2x squared plus 11x plus 15 on the inside. Since x plus 3 is a binomial, I want to consider the first two terms, 2x squared plus 11x. I need to multiply x by something that will give me 2x squared. X times 2x will give me 2x squared. I need to cancel this term completely, and since I'm going to subtract, they have to be exactly the same. Now I want to multiply 2x times the 3. 2x times 3 gives me a positive 6x. I'm going to subtract. The subtraction goes to both terms, so I need to subtract the 2x squared and subtract the 6x. 2x squared minus 2x squared is 0, which is what we wanted. 11x minus 6x is 5x. Bring down the plus 15. And now I need to multiply my x by something that will give me 5x. So that's a positive 5. 5 times x is 5x. Again, they have to be exactly the same. 5 times 3 is 15. I'm going to subtract, so that changes the sign for my 5x and my 15. 5x minus 5x is 0. 15 minus 15 is also 0. So my remainder is 0. 2x squared plus 11x plus 15 divided by x plus 3 is 2x plus 5. My divisor is x plus 3. My quotient is 2x plus 5. My remainder is 0. Using FOIL, x times 2x is 2x squared. X times 5 is 5x. 3 times 2x is 6x. 3 times 5 is 15. So that gives me 2x squared plus 11x plus 15. Add 0 to that, and I get my dividend. In this example, perform long division. 15x squared plus 14x minus 6 divided by 3x plus 4. So 3x plus 4 is on the outside of my division symbol. 15x squared plus 14x minus 6 is on the inside. So I need to multiply something by 3x that will give me 15x squared. 5x times 3x is 15x squared. Now I need to multiply by the 4. 5x times 4 is 20x. I'm subtracting. 15x squared minus 15x squared is 0. 14x minus 20x is a negative 6x. Bringing down my minus 6, I now need to figure out what times 3x gives me a negative 6x. It's minus 2. Minus 2 times 3x is negative 6x, and minus 2 times 4 is minus 8. Negative 6x minus a negative 6x is the same as negative 6x plus 6x, which is 0. Negative 6 minus negative 8, which is the same as negative 6 plus 8, gives us a remainder of 2. So my answer is 5x plus 2 plus my remainder of 2 over my divisor, which is 3x plus 4. In this example, perform the long division. 15x to the third minus 4x squared minus 24x minus 11 divided by 5x plus 2. 5x plus 2 goes on the outside of my division symbol. 15x to the third minus 4x squared minus 24x minus 11 goes on the inside. I need to cancel the 15x to the third, so I need to decide what times 5x gives me 15x to the third. I want to use 3x squared. So 3x squared times 5x is 15x to the third. 3x squared times 2 is a positive 6x squared. Subtracting, I have 15x cubed minus 15x cubed, which is 0. I have negative 4x squared plus a negative 6x squared, which gives me a negative 10x squared. Bringing down the minus 24x, I now need to get rid of the negative 10x squared. So minus 2x, when I multiply that by 5x, will give me a negative 10x squared. A minus 2x times a positive 2 is minus 4x. Subtracting, I have negative 10x squared plus 10x squared, which is 0. Then I have a negative 24x plus 4x, which gives me a negative 20x. Bringing down my minus 11, I now need to find what times 5x gives me a negative 20x, and that's a negative 4. Negative 4 times 5x gives me a negative 20x. Negative 4 times 2 gives me a negative 8. Subtracting, negative 20x plus 20x is 0. Negative 11 plus 8 is a negative 3. So my final answer is 3x squared minus 2x minus 4 plus a negative 3 over 5x plus 2. Perform long division. 27x to the third minus 64 divided by 3x minus 4. So I have 3x minus 4 on the outside. Then on the inside, we are missing several terms. To make the long division as easy as possible, we need to start with our 27 x to the third, then we need x squared, x, and then a constant. So I can write plus 0x squared as a placeholder. The same thing for my x to the first, so plus 0x minus 64. This way, when I do my division, everything will line up properly. I need to eliminate the 27x to the third. 9x squared times 3x will give me 27x to the third. 9x squared times a minus 4 is a minus 36x squared. So my like terms have lined up. Subtracting 27x to the third minus 27x to the third is 0. 0x squared plus 36x squared is a positive 36x squared. Bringing down my 0x, I now need to decide what times 3x gives me 36x squared. Positive 12x. So 12x times 3x is 36x squared. 12x times a minus 4 is a negative 48x. Since I'm subtracting, it changes my signs. 36x squared minus 36x squared is 0. 0x plus 48x is 48x. Bring down my minus 64. Now I need to decide what times 3x gives me 48x. Positive 16. 16 times 3x is 48x. And 16 times a negative 4 is a negative 64. Subtracting will change the signs, so I have 48x minus 48x, which is 0, negative 64 plus 64, which is 0, so I don't have a remainder. My answer is 9x squared plus 12x plus 16. In this example, I want to perform the long division for 6x to the third minus 11x squared plus 5 divided by 2x minus 1. Here I have x to the third, x squared, and a constant, so I'm missing x to the first. 2x minus 1 on the outside divided by 6x to the third minus 11x squared plus 0x as my placeholder plus 5. To eliminate 6x to the third, I have to multiply 2x by 3x squared. So 3x squared times 2x is 6x to the third. 3x squared times minus 1 is negative 3x squared. Subtracting, I have 6x to the third minus 6x to the third, which is 0. Negative 11x squared plus 3x squared, which is negative 8x squared. Bringing down my 0x, I now need to eliminate negative 8x squared. A negative 4x times 2x will give me a negative 8x squared. Negative 4x times negative 1 is a positive 4x. Changing my signs, because I am subtracting, I have negative 8x squared plus 8x squared, which is 0. 0x plus a negative 4x is a negative 4x. Bringing down my plus 5, I now need to eliminate negative 4x. Negative 2 times 2x will give me a negative 4x. Then negative 2 times negative 1 is a positive 2. Subtracting, negative 4x plus 4x is 0. 5 minus 2 is 3. My final answer is 3x squared minus 4x minus 2 plus 3 over 2x minus 1. Again, our remainder is dividing polynomials, long division. Dividing by a monomial. When you're dividing by a monomial, just separate your numerator into different fractions. If I have a binomial in my numerator, I'll have 2 fractions. If I have a trinomial in my numerator, I'll have 3 fractions. Dividing by a binomial. Long division can be used to divide by a binomial. You write your binomial on the outside and then the numerator on the inside. We always need to eliminate the first term, and you always subtract. When you're done, if you have a remainder, it goes over the divisor and adds on to the end of the polynomial.